Okay, let's expand and simplify this expression using some identities. And what do we know here? We know that cos of alpha plus beta is equal to cos alpha times the cos of beta minus sine alpha sine beta. And I'm hoping that you have a formula sheet with this if you're working on some identities. Great. So let's expand cos of x plus 90 using this formula. Given that our x will be the alpha, right, the a here, and our beta will be 90 degrees. So we get cos of x times cos of 90 degrees minus sine of x times sine of 90 degrees. Great. Now at this point, all we need to do is evaluate cos of 90 degrees and sine of 90 degrees. You can, nothing will prevent you to figure them out using a calculator. But I won't do that. I will also show you how to find these values with the unit circle. And I'm going to assume that you know what I'll be doing. If not, you can just use a calculator and skip this part of the video. So, for the unit circle, if the radius is 1, every point on the unit circle, x comma y, will give us x for cos of theta and y for sine theta. Okay, so if we're looking at 90 degrees right here, and we always start here, right? And we go over to 90. This point is 0, 1. So that's the x value, that is the y value. So the cos of 90 degrees will be just the x value, which is 0. So it's equivalent to 0. And the cos of, now we're interested in actually the sine of 90 degrees. Sine of 90 degrees, like I said, sine of theta, angle theta is equal to y. The y value is 1. I should have written y value for the sake of... Okay, so sine of 90 degrees is 1, so I can plug a 1 in here and a 0 in there. Then we can simplify this. So cos x times 0 minus sine x times 1. Cos x times 0 just gets written off. 0 times anything is 0, so that's gone. And 1 times sine of x is just negative sine x. Look at that. So the whole thing here, cos x plus 90 degrees is negative sine x. And of course, you would have arrived at these values, 0 and positive 1, for cos 90 and sine of 90, if you just, of course, plug them into the calculator. And you would have also arrived at negative sine x. That's it.